Let's look at the distribution of exponents. Whenever you have an exponent that is outside of parentheses, then you are going to distribute it to everything within parentheses. In this case, we have distributing the m to both the base of a and the base of b. And so this is actually understood to be a to the first power times b to the first power raised to the power of m. And so what you're doing here is using that property that tells you this is a to the first to the m power times b to the first to the m power. And the property that tells us when we have a power raised to a power you should multiply is how we end up with a to the m, because 1 times m is m, times b to the m, because 1 times m equals m. Let's look at the next example. In the next example, we're going to take the exponent of 3 and apply it to everything within the parentheses. So this is the same as taking 2 to the first power and raising it to 3, and multiplying that by a to the first power being raised to 3. So write down what you think that equals. You should get 2 to the third, a to the third, and remember when you have a number raised to an exponent, you should multiply it out. So the final answer would be 8a to the third. So in the next example, we're going to raise 3 to the second power, and we're going to raise m to the fourth to the second power. So that's the same thing as taking 3 to the first power, it has that understood 1 as an exponent, and raising it to the second power. And then multiplying that by m to the fourth raised to the second power. So see if you can figure out what this would equal. You should end up with 3 to the second, m to the eighth, we're multiplying those exponents, which equals 9m to the eighth. Let's look at our next example. So we're going to raise x to the third to the sixth and y to the fifth to the sixth. Now, that's the same thing as the following. So when you raise an exponent to an exponent, what would you do? You would multiply. So what would you get here? X to the 18th times y to the 30th. Okay, now here, so this was all examples of having variables and numbers being multiplied together and those being raised to an exponent. Here we have division instead of multiplication. And if you'll, when we distribute with division, the m, or the variable, is going to go to everything that's inside of parentheses as well. It just happens to be division. So a, this is the same thing as a to the first raised to the m power over b to the first raised to the m power. And the first, when you have a to the first to the m power, you're multiplying 1 times m to get m, and b to the first to the m power 1 times m to get m. So that's how we get a to the m over b to the m. So try this next one. You should get 2 to the second divided by 3 to the second. And since these are numbers being raised to exponents, we want to simplify. And we're going to get 4/9. Now, you could also see this as 2/3 squared. It's actually the same thing. And 2/3 squared, this is actually the order of operations that you would use, because you would square everything. So you can do it either way, it doesn't really matter. All right, let's look at the next one. Try that, x over y to the fourth. You should get x to the fourth over y to the fourth. All right, now things get a little bit more complicated when we look at the next problem. We have to raise everything there to the third power. So give that a try. You should end up with 3 to the third, x to the sixth over y to the 15th. Now we always want to simplify those numbers, so we're going to multiply 3 to the third out. So 3 squared is 9 times 3 is 27. So 3 to the third is 27. X to the 6th over y to the 15th. Let's look at some harder examples. All right, give that one a try and then check back. You should have x to the 14th, y to the 21st, because we're just raising exponents to exponents, which is multiplication. Try this one. You should get 3 squared m to the 6 n squared, which is 9m to the 6 n squared. Try this one. You should end up with 3 squared n to the 12th, which is 9n to the 12th. Notice m to the 0 is the same thing as 1. 1 squared just equals 1, so you're just multiplying 1 times 3 squared times n to the 12th. So that 1 just kind of disappears because 1 times anything is itself. Now here you're going to want to be really careful in this next example. That negative 2 needs to stay in parentheses when you raise it to the 4th power, and that's important because if you'll remember, negative 2 to the 4th is going to be the opposite of 2 to the 4th. So that would be negative 16, whereas negative 2, the negative and the 2 being raised to the 4th is going to be positive 16. Okay, so here we end up with 16 x to the 12th, y to the 20th. Okay, try the next example. You should end up with 2 to the 4th, m to the 14th, n to the 8th, and 2 to the 4th is 16. Okay, try this next one. You should notice anything to the 0 power is 1, so the answer there is 1. All right, let's look at this next example. So what you're going to want to do here is multiply all the constants together first, and then multiply all of the same variables together. So we're going to multiply 3 times 2 times negative 6. So go ahead and try that. And so the negatives will always be a coefficient. Okay, it will go with a number, not with a variable. The variables are all positive. So now we're going to add the exponents. We're not raising an exponent to an exponent here. We're just multiplying same bases. So we add up all of those exponents and we get a to the 7th. So our answer is negative 36 a to the 7th. Let's look at the next one. Give that a shot. So you should multiply negative 5 times negative 3, m to the 4th times m to the 0, or you can just drop it because it equals 1, and n to the 1st. I recommend putting that first there to help you keep up with it, times n to the 1st. And we end up with 15 m to the 4th, n to the 2nd. Okay, so here we're going to follow our order of operations. Our order of operations here says to go in and distribute the exponents. So you do your exponents first, then you divide. So here we're going to do negative 5 squared is 25. M to the 4th to the 2nd is m to the 8th, because when you raise an exponent to an exponent, you multiply. And then n to the 1st to the 2nd is just n to the 2nd. 1 times 2 is 2. And then we're just going to bring over 2m squared n 0. Now we're going to simplify. So 25 and 2 cannot be simplified, so we leave the 25 and the 2. M to the 8th divided by m squared, we're going to subtract the exponents, so we end up with m to the 6th, because 8 minus 2 is 6. You always subtract numerator minus denominator with the exponents. And then we end up with n squared, because 2 minus 0 is 2. And that's the answer to your problem. Now, unlike the previous problem, in this problem you're going to divide first. You go inside the parentheses and you do what's inside the parentheses first, then you apply your exponent. Truthfully, it'll come out the same either way, but that's what the order of operations are telling you to do. So I'm going to simplify. Negative 2 over 4 is negative 1/2. And then x to the 5th over x to the 1st, we're going to subtract the exponents and get x to the 4th. And then y to the 4th over y to the 3rd, we'll subtract the exponents and get y to the 1st. Now, we still need to raise all of this to the 3rd power. So, negative 1 to the 3rd power is negative 1. X to the 4th to the 3rd power is x to the 12th. Y to the 1st to the 3rd power is y to the 3rd. And then 2 to the 3rd is 8. So that's your answer. Try this one last problem and then check in and see how you did. So here you should divide first. So you always do what's in parentheses first. So negative 5 goes into negative 10 positive 2 times. Then we're going to subtract our exponents. So for the x's, 2 minus 1 is 1. So we get x to the 1st power here. And then for the y's, we do 4 minus 0 is 4. So y to the 4th. And there's nothing in the denominator but a 1 now. So you can leave that there, or you could have just written it as 2x y to the 4th raised to the 4th. So now we need to simplify this. So 2 to the 4th is 16. X to the 1st to the 4th is x to the 4th, because we're multiplying our exponents. We're raising an exponent to an exponent. And y to the 4th is y to the 16th.